In this exercise, we're looking at the symmetry properties of circular functions. And really what we're going to be trying to do is relate everything back to the first quadrant. So let's talk about what a quadrant is. If you look at our diagram over here, you will see that it is a circle divided into 4 quarters or 4 quadrants. And the order of the quadrants is really important here. So that is the first, second, third and fourth quadrant. We always go in a anti-clockwise direction. Now the other thing that you would be aware of is that when we go around a circle, we start at 0. This is 90 degrees, or the equivalent in radian would be pi on 2. When we go around again, this is 180 degrees, and the equivalent in radian is pi. And down here we're at 270 degrees, which is 3 pi on 2. And of course we come back to 360 degrees, which is equivalent to 2 pi. So it's very important that we can identify things in degrees and radian, because we will be working in both. And we do know that a circle, right around a circle, is 360 degrees. Again, if I went around again, another full cycle, then that would be 720 degrees. The relationship between all of the quadrants means that we can relate everything back to the first quadrant, the angle in the first quadrant, as long as that angle in that first quadrant is an acute angle. So the angle in the first quadrant is theta. Okay, it's theta. And therefore, in the second quadrant, the relationship of that angle to the first quadrant is pi minus theta. In the third quadrant, the relationship between the third quadrant and the first is pi plus theta. And then in the fourth quadrant, it is 2 pi minus theta. So if I was doing it in degrees, that would be 180 minus theta. This would be 180 plus theta. This would be 360 minus theta. So we can work in degrees and radian and relate everything back to that angle in the first quadrant. Another thing that we really need to know is where sine, cos and tan are actually positive. So the way that we remember that is to use cast. Now another way that I remember it is all sing the chorus, where the first letter of each word gives you what is positive in what quadrant. So all in the first quadrant, sine in the second quadrant, tan in the third quadrant, and cosine in the fourth quadrant. So all are positive in the first, only sine is positive in the second, tan is positive in the third, cosine is positive in the fourth. All sing the chorus, or if you're starting from here, C-A-S-T, cast. When given a negative angle, it's always easier to work with a positive angle. So this is something that we need to remember, is that the sine of a negative theta is negative sine theta. The cos of negative theta is positive cos theta, and tan of negative theta is negative tan theta. Again, it all relates back to that angle in the first quadrant. Let's have a go at some of these questions with regards to symmetry. So just remember, theta, pi minus theta, pi plus theta, 2 pi minus theta. So all sing the chorus. So here we're told that sine x is equal to 0.8. Find the value of sine of pi minus x. Okay, pi minus x or pi minus theta, what quadrant are you in? Well, if you have a look up, we are in the second quadrant. And is sign positive or negative there? Sign is positive because it's sing. So therefore, sine of pi minus x is exactly the same thing as sine of x. And therefore, our answer is 0.8. Okay, what about the next one? Sine of pi plus x. What quadrant am I in there? I am in the third quadrant, and so therefore sine is negative in that quadrant. So I end up with negative sine of x, relating it back to the angle in the first quadrant, and therefore my answer is negative 0.8. Next one, I am obviously in the fourth quadrant, 2 pi minus x or 2 pi minus theta. So relating it back to the angle in the first quadrant, it is sine of x. Now is sine positive or negative in that fourth quadrant? Well, it is negative because cos is positive, so it's a negative sine x again, and therefore negative 0.8. So remember, everything is related back to that first quadrant, and then we look at what quadrant the original one was in to work out our sine. What about this one here? Sine of negative x. Well, look back up to our rule. Sine of negative x is the same thing as minus sine of x. All right. And minus sine of x is, well, we know 0.8 is sine of x, so again it's negative 0.8. The next example asks us to evaluate. All right. Again, we're looking at the symmetry here, and we're also looking at our negative and positive angles. Now, what I've got here is actually cos of negative theta. And so we know that that's the same thing as just cos of theta. So really all I'm looking for is cos of 3 pi on 2. And if we go back to our circle, we know that cos of 3 pi on 2 is equal to 0. That goes back to the fact that our coordinate there was 0 minus 1 at 3 pi on 2. And we always look at the x ordinate for our cos. So let's have a look then at sine, and this is the same thing as sine of minus theta, and therefore it is the same thing as minus sine of pi on 2. Now sine of pi on 2, the coordinate there is 0, 1. Okay, 0, 1. When x is 0, y is 1, and we're looking for our y value, so therefore it would be minus 1. So that's how we use symmetry to relate everything back to the first angle in the first quadrant, as long as it's an acute angle, and we have to put all of that information we've got together.